Okay, so here's our problem set for subtracting mixed numbers. We're going to find the difference and show all of our work. Before I can subtract these fractions, what do they need? They need a common denominator. So let's come over here and let's multiply. Whoops, let's change that to multiplication. Multiply by our giant 1. Giant 1. And what denominator do we want? Let's see. Let's do 4 as our denominator because 2 can multiply to be 4, 4 can multiply to be 4. 4 times 1 is 4, 3 times 1 is 3, 2 times 2 is 4, 1 times 2 is 2. Again, I multiplied by 1 so that I don't change the value. So now let's rewrite it. We have 5 and 3/4 minus 2 and 2/4. Subtract the fractions first. 3/4 minus 2/4. Again, we're just looking at this 3 and this 2. The denominator is going to stay a 4 since they're both the same size pieces now. 3/4 minus 2/4 is 1/4. 5 minus 2 is 3. Let's look at this one. Let's make our giant 1 so we get a common denominator. And I know 3 can multiply to be 9, and 9 can multiply to be 9. So that's a denominator I would like to use. 9 times 1 is 9, 8 times 1 is 8, 3 times 3 is 9, 1 times 3 is 3. So let's rewrite our problem. 7 and 8/9 minus 5 and 3/9. Subtract the fractions first. 8/9 minus 3/9 is 5/9. 7 minus 5 is 2. 2 and 5/9. Okay, let's multiply by our giant 1, just the fraction piece. I'm writing this like this, but I'm only multiplying the fraction piece. I'm not actually multiplying the whole number, even though I guess I could since it has a value of 1. It would still be that whole number. Okay, and let's see. I know that 3 can multiply to be 3, 6, 9, 12, and 12 can multiply to be 12, so I know I can use 12 as our common denominator. 3 times 4 is 12, so that I keep this the same value. 1 times 4 is 4. 12 times 1 is 12. 11 times 1 is 11. So I'm going to rewrite this as 15 and 11/12 minus 4/12. 11/12 minus 4/12 gives me 7/12. 15 minus that invisible, oops, it's a 4. 15 minus 4, can't forget that 4. 15 minus 4 is 11. There we go. Okay, again, let's find that common denominator. We need the same size pieces if we're going to add or subtract. It does not matter for multiplication, but it matters for addition and subtraction. Our common denominator is going to be 10. 10 times 1 is 10. 9 times 1 is 9. I know I can use 10 because 5 and 10 can both multiply to be 10. 5 times 2 is 10. 2 times 2 is 4. Rewrite my problem as 13 and 9/10 minus 4 and 4/10. 9/10 minus 4/10 is 5/10. 13 minus 4 is 9. Now 5/10 I happen to know I can reduce that fraction, so let's go ahead and divide top and bottom by 5, and we get 9 and 1/2. 9 and 1/2 if we reduce it. It didn't ask us to reduce it, so both of these answers are correct. This is just the reduced one. Martha read 3 5/6 books over the summer. Charlotte read 2 1/3 books over the summer. Which expression could be used to determine how many more books Martha read than Charlotte? How many more typically tells us a subtraction problem. So here's our 3 5/6 minus 2 1/3. How many more did she read than she read? Okay. Now, to do this, remember from our last problem, this is the same as 3 plus 5/6 minus 2 plus 1/3. Those are the same because I can use this addition to create this mixed number. I can use this addition to create this mixed number. So I'm going to apply that here. Since I have some addition, because they've now separated our whole number and our fraction pieces, I need some addition in this problem since we separated those. So I'm going to cross off A and C because those cannot be the answer because they don't have any addition. That would be like saying 3 minus 5, 6. Well, that's not what we're doing here. We're not doing that math. So it's down to these two problems. And I'm going to look, I can use a common denominator of 6. And this one I can multiply by 1 over 1 to get 5, 6. Here I'm going to multiply by 2 over 2 to get 2, 6. I think I found my answer. My answer is D. My answer is D. If you look here, they forgot to change the numerator. It's not an equivalent fraction to over here. Now let's actually check our work with this. 3 and 5, 6 minus 2 and 2, 6. 5, 6 minus 2, 6 is 3, 6. 3 minus 2 is 1. If I wanted to reduce that, I would get 1 and 1/2. Okay? If I do this math, I end up getting 1 plus 5, 6. Well, 1 plus 5, 6 is 1 and 5, 6. 1 and 5, 6 minus 2, 6 gives me 3, 6, 1, 1 and 3, 6. So I still got the same answer with letter D. Number 6. The length of Mr. Cho's garden is 8 and 5/6 feet. Find the width of Mr. Cho's garden if it is 3/16 feet less than the length. So that means my problem is going to be 8 and 5/6 minus 3 and 1/6. 8 and 5/6 minus 3 and 1/6. 5, 6 minus 1/6 is 4, 6. 8 minus 3 is 5. So I could have an answer of 5 and 4/6. Or I could reduce that fraction and get 5 and 2/3. And it said feet, so we're going to write feet. Okay. Timberly spent 3 4/5 hours and Misty spent 2 1/10 hours at gymnastics practice over the weekend. How many more hours did Timberly spend than Misty at gymnastics practice? So we're going to do how many more did she spend, or he, than Misty. So in order for me to do that, I'm going to rewrite my problem vertically. It's easier for me to subtract that way. And I'm going to get a common denominator. So let's go ahead and multiply by a giant 1 so we don't change the value. And let's use a denominator of 10 because 10 can multiply to be 10 and 5 can multiply to be 10. 5 times 2 is 10, 4 times 2 is 8. So now my problem is 3 8/10 minus 2 1/10. 8/10 minus 1/10 is 7/10. 3 minus 2 is 1. Timberly spent 1 7/10 hours more at practice.